is my slope. Do we remember that word? Bless you. Do we remember that word? Yes, no, maybe? Come on, talk to me.
Yes.
Remember slope? We'll see if we remember slope. And B is our y-intercept. And B is our y-intercept. Yes. Okay. Exponential. This is the equation we dealt with yesterday. Y equals A times B to the x power. You got to know the difference between the two of them. Luckily, there's a lot of different variables being used, so that's helpful. Y equals A times B to the x power. Where A, what's A represent? Huh? Ooh, not yet. That's me. A is my y-intercept, or starting value. B is my growth, or decay factor. This is a must. We must kind of remember these pieces. Because next week when we really dive into the equations, guys, I'm just going to give you an equation. I'm going to say you have to graph it. And you're going to be able to graph it based on these things. Not going to do that today, but we are going to do it. Now, if I ever give you a table, all a table is one is, it's usually going to say, hey, what kind of function is this? And there's actually three. We're going to add one later. It's going to say, what kind of function is this? Well, if it says what kind of function is this, there's two ways of doing it. There's the easy way, which I'm going to show you today, which you'll like. And there's a not as easy way, which we'll do tomorrow, but you'll be fine with it as well. The easy way is to take that table and plug it into what? Desmos. How do we plug a table into Desmos? You have Desmos open, yes? Open Desmos, please. Open Desmos, please. I don't think I even have Desmos open. Open Desmos. How do I put a table into Desmos? What? The plus sign and table, right? Yes? Copy your table into Desmos. So 0, 0, 1, 5, 2, 10, 3, 15. So copy it in. Boom, 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 boom. Once you have it copied in, look up here for me, please. Do we see all the data points? No. So guys, I'm going to zoom out a little bit. Now, here's what you're looking for. You're looking for the shape of the points. So look up here. What does a linear line look like? It either looks like this, right? Or it looks like that, right? It's a straight line. What did exponential growth look like? It looked like a J, right? And decay looked like, did I just do that? And decay, did I do a J?
Yeah, you went backwards.
So it looks like this. You guys know what I mean. Okay, struggle. All right, now look at this line, or look at these points. Do they look like they're making a straight line, or do they look like they're making a J or an L? So give me one that you know it isn't. Does it look like an L? No, so we know it's not exponential decay. Could it possibly look like a J? No, but maybe yes. Is it going to be decreasing linear? Is it going down? No, so we're between two, right? We're between linear, increasing, or exponential growth.
That's 3 things here too.
No. Linear increasing is 1. Exponential growth is 2. The increasing linear line. It's not three things. Increasing and linear are the same thing. What? No. I said it's not something. I said it's either linear increasing or exponential growth. What do you think I said? Well, I want to clarify. If I said something, then I need to clarify. Those are your two. Now, to make 100% sure you know what it is, you are going to type this into Desmos. Does anybody remember this squiggle equation for the exponential? Do you remember we type in y1? Everybody's typing this in, please. y1. Where's the squiggle button? Shift to the left of number 1. Then I put in what? A, B, to the x1. So put that in. Everybody have that in? Yes? In box 3, I want you putting something else in. Watch this. Type in this. y1, squiggle, mx1 plus b. I want you to put both of them in. Jocelyn, does that help? If I make it bigger? What? Now, I want you guys to look right here. See where it says r squared right here? And you see where it says r squared right here? Don't touch yours. Look at mine. There's the quadratic. I'm sorry, there's the exponential. Yes? Does it kind of hit some points? Look up here. Does it kind of hit some points? Yeah? Okay. Now look at this linear one. Does it hit all of them? Now, here's the deal. This is going to be really helpful for you, and the air test doesn't expect teachers to have figured this out, but we're smarter than them. What you want to look for is you want to look for this r squared number, and it wants to be as close to 1 as possible. So which one's closer to 1? 1 or 0.92? 1. So is this linear or exponential? It's linear, and it's linear increasing or decreasing? Increasing. Right? I got another table, right? Do I have another table? Yeah, so what am I going to do? I'm putting decimals. Now, kiddos, I'm not going to get rid of either of these two squiggles. I'm going to put it in decimals. So 0, 1, 1, 2, 2, 4, 3, 8. Come on, don't spend a zillion hours writing stuff down. Put stuff into decimals. Write it down. Unacceptable. I want some of you guys to realize that second, third, and fourth quarter are harder than first. If we don't do the work, then you're not going to pass. I hate to break it to you. I don't want to tell you, but that's what it is. 0, 1. Oh, come on. Did you get rid of this? Keep that. What are you doing over here, crazy? I don't either. Okay. Yes, sir.
I already have the answer for this.
What is it?
I mean, I know the name for it, but it's like Jailer.
I said JLOOK you want, right? Because if you click both of these, boom, and boom, which one's closer? Now the problem is this one. Is this Y1? Did I put this as Y1? Is this changed? Which one's closer?
The black one.
Is it the black one
Yes.
or is it the red one? It's the black one. No, stack, there it is. Okay, the black one, because what does r squared equal? What does r squared equal right here? No. What does r squared equal? R squared equals 1. We want it to equal 1. So this is exponential. But is it growth or is it decay?
Growth.
It's growth because it makes a J. And it's going to put exponential growth. Because you are going to have to, on your homework this evening, tell me if it's linear increasing, linear decreasing, exponential growth, exponential decay. Now, question. I need to graph them. If it asks you to graph something, what are you immediately going to do? What? I thought you said put it in Netflix, and I was like, okay, that's not going to do you any good, but sure. Put it into Desmos. So my equation is y equals 3x plus 2. Y equals 3x plus 2. Does everybody have that? What do we immediately do? Click on the points it's given to you. Can I use this one? Why not? It's not pretty. Can I use this one? Yeah, so I have 1 point. How many points do I need to graph this? 2. So I know I have 0, 2, so you graph 0, 2 on your graph paper. Graph 0, 2. 0, 2. Right there. How am I going to find my other one? You got it. Type in x equals 1 and look for where they what? Intersect. Do they intersect? Yep. Can I plot that point? Yeah, why? It's a pretty point. So I'm going to do 1, 5. And what am I going to do with those two? I'm going to connect them like so. That is not the hard part in my opinion. The hard part is what comes right here. It's your domain and it's your range. Okay, pencils down, ears turned way up. Does everybody have the graph on there? Domain, X or Y values? X. So remember what we asked ourselves. When we come from the left, do I hit a point or do I hit an arrow?
Arrow.
You hit an arrow. If you hit an arrow from the left, what does that mean? What? Negative infinity. Don't pick up your pencils yet. What do I put around that negative infinity? Good. When I come from the right, point or arrow?
Arrow.
Arrow, so that is positive infinity within a parentheses. Write it down quickly, please. Very proud of you guys remember that. That's awesome. I want you to remember that the whole time.
Like maybe a little hard.
Oh, okay. Sorry. Range. Come up from the what? Bottom. Point or arrow?
Arrow.
Arrow, so that is negative infinity. Come down from the top. Positive infinity. With parentheses. Nice job. Okay? What about the next one? Y equals 3 parentheses 2 to the x. What do I do with that? Put it into Desmos. Oh, not 20. How many gray dots do I have? 1. Is that pretty? Can I graph it? Yep. So graph 0, 3. So graph 0, 3. Okay, let's talk. Is this growth or decay? How do we know? The J shape. Where's going on? I'm fine with that. Alright, if it's growth, how do I find my next point? Say it louder, Javante. X equals 1. What do I look for? Where they? Do they?
1, 6.
1, 6, is it pretty? Yep. So I come back here. 1, 6. Now, kiddos, there's one thing that I want to make sure you really understand. Remember how I said it kind of tails off yesterday? Does this one tail off somewhere? Where does it not, what number does it not go under? It doesn't go down here at all, right? So when you graph it, you need to make sure you try your best not to cross that x-axis. It's the first time we're graphing these, so I'm not going to be super, I'll be okay. Does anybody remember what the domain is? You got it. Every single time. It's negative to positive. Whoa. Every single time, it is negative to positive. Do we feel pretty comfortable with this? This isn't bad, right?